let's look at the question given to us. We are having tan 58 degrees equal to n. We are required to determine the following in terms of n. So now you start off with a mini right angle triangle. I'll draw it alongside here. This is my mini right angle triangle. This is 58 degrees. The remaining angle is 32 degrees. Then my opposite, because we know the definition for tan, it's a opposite divided by the adjacent. This will be n, this will be 1. So now we are supposed to find sine 58 degrees, but what is the definition for sine? The definition for sine is opposite divided by the hypotenuse. We lack the hypotenuse, so we need to find the hypotenuse. So now this is what you do. You are going to utilize the theorem of Pythagoras. We are going to say r squared is equivalent to n squared plus 1 squared. Thereafter, this is r squared equal to n squared plus 1. Then r it's the same as square root of n squared plus 1. Then now our answer here will just be the opposite, which is n, divided by the hypotenuse, which is the square root of n squared plus 1. That's it. We are done with the first question. 5.1.2, we are having sine 296. So this sine 296, it may appear a bit tricky, but it's not that tricky. If you check, suppose we try to use the reduction formula. We say 180 degrees plus the angle that we have, it gives us 238, but subtract that answer that you have from 296. If you observe, we are in need of 58 degrees, so we can simply write this as sine into 2 multiplied by 58 degrees plus 180 degrees. And it can also be written properly as a sine into 180 degrees plus 2 multiplied by 58 degrees in this particular fashion. Ultimately, sine 180 plus an angle will simplify to negative sine of that angle, which will be 2 multiplied by 58 degrees. This is a double angle for sine, so it can be expanded to give us negative 2 sine 58 degrees multiplied by cos 58 degrees. Remember, for us to get to this, I'm saying sine 2 beta, from what we know, is the same as 2 sine beta multiplied by cos beta. This is what we all know. So hence I expanded this like this particular way, in this particular way. So now we substitute, this is negative into sine 58 according to what we've done up there, just n divided by the square root of n squared plus 1 multiplied by, sorry, I've left that 2, I will get to it. Cos 58 degrees, it's adjacent divided by the hypotenuse, which is just 1 divided by root of n squared plus 1. But remember, we have a 2 here, so I'll bring in that 2. We have a 2 here, so this can be written as negative 2 multiplied by this that we have here. Thereafter, this will just be negative 2n divided by n squared plus 1. That's it. That's the answer to that particular problem. So now let's delve into the last question of them all. The last question. I made a mistake. I erased that which was not supposed to be erased. So now we also have in our midst cos 2 degrees. One can ask, how does cos 2 degrees relate to this which that we have here, right? Suppose I am to say cos into, I try with reduction formulae, the 180, 90, 270, it doesn't work, right? But from the angle that I have and another angle that I will bring in, which is a special angle, I can just say 60 degrees minus 58 degrees. I will get 2. But when I look at my right hand side, it's a bit complicated. We refer to this as a compound angle. So a compound angle for cos can be expanded. The expansion of a compound angle for cos, we know that cos into theta plus beta is same as cos theta cos beta. If in the middle it's minus, let's use the one that has got a negative, we'll have plus sine beta sine theta. So we are going to expand this using the expansion for cos. This is cos into 60 degrees minus 58 degrees. In expanding this, we are just going to remain with cos 60 degrees, cos 58 degrees, plus sine 58 degrees and sine 60 degrees. So 60 degrees is a special angle, but the 58 degrees is what we have in our diagram, so we can determine it directly from the diagram. So now let's proceed in solving the problem. What is cos 60 degrees? Cos 60 degrees, according to the special angles, it's same as half. You'll say half multiplied by cos 58 degrees. Cos 58 degrees according to the diagram, remember this one was a root of n squared plus 1. So it will be adjacent, which is 1 divided by the hypotenuse, which is the square root of n squared plus 1, then plus sine 58 degrees according to the workings up there is just n divided by the square root of n squared plus 1 multiplied by sine 60 degrees. In our case, sine 60 degrees according to the special angles, it's root of 3 divided by 2. Then with this you can get to the final answer. You will finalize it. Now let's go to the second problem. Now we are having our 5.2 here. We are required to prove the identity given to us. So from the trigonometric identities, remember when you deal with identities, you need to bring in everything that has to do with identities. Let's pick the difficult side or the complicated side. On my end, I can see that the difficult or the complicated side is the left hand side, which is 1 minus cos 2x divided by sine 2x. So if you check, sine 2x and cos 2x are a bit complicated, but we know that sine 2x is same as 2 sine x cos x. It's a double angle for sine, and also the double angle for cos is just cos 2x can be written as 1 minus 2 sine squared x, and it can also be written as 2 cos squared x minus 1, and also it can be written as cos squared x minus sine squared x. So in our case, we are going to change this thing in this particular fashion. Remember, we are working while list checking what we have on the right hand side, we want to get to tan, but we know that the definition for tan, it's just tan is an identity which is the same as sine divided by cos. So what you simply do, in the denominator you want to remain with cos, so you are going to divide, you try to change you change sine 2x to be 2 sine x cos x. Then that which we have up there, which is 1 minus cos 2x, we can change cos 2x to be, we'll just say this is 1 minus into, let's write it as 1 minus 2 sine squared x. We are doing this thing deliberately. This will be 1 minus 1 plus 2 sine squared x, all divided by 2 sine x cos x. Thereafter 1 minus 1 is just a 0. This is 2 sine squared x divided by 2 sine x cos x. Let's use arrows here because this is not an equation, but it's an expression. So thereafter this will just be 2 sine x multiplied by sine x divided by 2 sine x cos x. Thereafter these two will divide each other. We remain with sine x divided by cos x, which will further simplify to tan x. Therefore left hand side is same as the right hand side. Now looking at the second question, which is 5.2.2, they are saying use the identity above to determine the value of tan 15. Tan 15, the 15 degrees is in our case, when we compare it to the previous question, the same as x. So what we normally do here, you will simply say, using the above, we are going to say 5.2.2 can be written as 1 minus cos into 2 multiplied by 15. We are just plugging in 15 degrees as the angle in question. Ultimately, where we see sine 2x, that sine 2x can further be written as sine into 2 multiplied by 15. You just plug in 15, nothing more, nothing less. This will be 1 minus cos 30 degrees. Remember, 2 multiplied by 15 just 30, divided by sine 30 degrees. This will be 1 minus cos 30 degrees. We know that it's the same as root of 3 divided by 2. We divide everything by sine 30, which is half. Then you'll calculate, you'll get to the final answer, then that's it. That's how you solve that problem. Now let's look at this problem here. It's a simple problem that doesn't need rocket science. One can simplify that problem in this particular fashion. We need to simplify it to a single trigonometric ratio, right? So this one, it's a reduction formula combined with co-functions, you see. So let's change the font color. So now in solving that problem, sine 360 degrees plus can be changed to positive sign. Remember, that value, it's located in the first quadrant. So in solving our problem, we can just say this is the same as sine x multiplied by, I reiterate, 360 degrees plus. It's found in the first quadrant and all ratios are positive in the first quadrant. You multiply this by cos 90 degrees plus x. Remember, cos 90 plus cos 90 minus sin 90 minus and sin 90 plus. They change to their core ratios or to their core functions. So this will change to negative of sin x. Then minus, then we bring in the division line here. Let's change the font color because we are writing different things here. We retain the sin x, we do not change it. But then cos of a negative angle, remember negative angles are in the third, in the fourth quadrant, and cos is situated in the fourth quadrant. It's positive in the fourth quadrant, so this will just be cos x multiplied by tan 360 degrees minus. Remember, 360 degrees minus is in the fourth quadrant, and tan is positive in the third quadrant. So this will just be negative tan x. This will be negative tan x. Sorry. Yeah, it's negative tan x. Subsequent to this, we can just write this as negative sin squared x minus sin x. We don't know if we'll need to come back and re-simplify it, but then we will see. Cos x multiplied by, remember tan x has got its identity. It's the same as negative sin x divided by cos x. Now moving forward, these two will divide each other. We remain with negative sin squared x minus sin x, all divided by negative sin x. So this will further simplify to negative sin squared x plus 1, which can also be rewritten as 1 minus sin squared x. But you need to bear in mind, according to the square identity in trigonometry, we know that cos squared x, if you transpose sin squared x to the other side, this will be 1 minus sin squared x. So this can further be written as cos squared x.